So meanwhile, I'll type the question in the chat box. Go through the problem number 4. Yes. Say problem number 4. A cube of side length 60 mm is resting on one of its faces on HP with a vertical face inclined at 40 degrees to the VP. With a vertical face inclined at 40 degrees to the VP. So cube having all the sides, all the faces are equal shape and size. It is resting on one of its faces on the HP. So we can see the true shaping top view, and while drawing top view one more condition is given. One of the vertical face is inclined at 40 degrees to the VP. One of the vertical face is inclined at 40 degrees to the VP. So first to draw XY line. And cube in top view with one of the face inclined at 40 degrees to the vertical plane. So draw inclined line at 40 degrees. Based on this line, complete the construction of square. So let the corners be A, B, C, D. 4 corners on top and 4 corners on the base. E, F, G, and H. Now draw the projections from each and every point. Draw the projection from each and every point. Draw the projections from each and every point and check the problem. What is the condition? It is resting on one of its faces. As it is resting on one of its faces, so we should start the front view on XY line. We must draw the front view on XY line. So on the front view base, it must be on XY line, and from this point, the cube must be extended. What is the height of the cube? So for cube height is nothing but the side length. So side length is given as 60 mm in the problem. So extend each and every side. So let it the base. So while drawing top view, we assume that A, B, C, D are visible, E, F, G, H are hiding. So it implies E, F, G, H are the points on the base, which is resting on ground, and A, B, C, D are on the top. So mark the points E, F, G, H. E dash, F dash, G dash, and H dash. So for cube, axis height is equal to the length of the side. Extend each and every point up to a height of 60 mm. Now, what are the points? If we observe when drawing front view, this is the viewing direction. So this is the viewing direction. B, F edge is visible. B, F edge is visible. So draw the B, F edge as a continuous line. So this is A dash, B dash, C dash, and D dash. AE visible, BF visible, and CG visible. Hiding point is the point which is nearer to the XY line. The point which is nearer to the XY line, that is DH edge is hiding. So draw DH with a dashed line. Draw DH with a dashed line. So with this we completed the projection of a cube. And along with this, don't forget to draw the axis. So axis, for drawing axis, join the diagonals with 2H pencil to get the intersection point. Mark this as O comma O1. Draw the projection from O comma O1 and indicate the axis line. Indicate this axis line. Finally, the dimension. So represent the dimension to any one side. Side length equal to 60 mm. Actually, this is also a simple problem, but a cube, a different shape. That's why I'm explaining it as a different problem. So it is angle 40 degrees. So this is how to draw the projections of a cube. So only variation for a prism and a cube is, for cube the axis length equal to side length. So remember this condition. Now let us move on to the problem number 6. Final, at the end we'll do the problem number 5. Next, go for the problem number 6. I'm typing it in the chat box. A regular pentagonal prism, side of base 40 mm and length of axis 80 mm. The two dimensions are side of base 40 mm and axis length 80 mm, lies with one of its rectangular faces on the ground. Lies with one of the rectangular faces on the ground. Axis inclined at 40 degrees to the vertical plane. The axis is inclined at 40 degrees to the vertical plane. Draw the projections of the prism. Draw the projections of the prism. So first identify the inclination. The axis is inclined at 40 degrees to the vertical plane and resting on the ground. If we assume this as the ground, this is the position of the prism. So with the initial condition, axis perpendicular to the VP, but it is given as the axis is inclined to the vertical plane. The pentagonal prism is resting with side of base with one of its rectangular faces on the ground. It is resting with one of the rectangular faces on the ground and axis is inclined at 40 degrees to the vertical plane. Axis is inclined at 40 degrees to the vertical plane. So whenever the axis inclination is given, first assumption must be make the axis perpendicular to the reference plane. Make this axis perpendicular to the reference plane. So as the axis is inclined 40 degrees to the VP, make this perpendicular to the vertical plane. So in this condition, in which we can see the true shape of the base, in which we can see the true shape of the base, front view or top view? Any of you unmute your audio and respond. In which view you can see the true shape of the base when the axis is perpendicular to vertical plane. Actual problem is axis inclined at 40 degrees, but for drawing the true shape of the base, we assumed the axis perpendicular to the vertical plane. Ever answer Chedla?
Top view, sir.
In top view or front view?
Front view, sir.
Front view. In front view, you can see the true shape of the base. So start the problem with front view. As in problem, it is given that it is resting with one of its rectangular faces on the ground. You must draw the pentagon starting from XY line. Starting from XY line means considering the first base on XY line. Let this be A dash, B dash, Same 108 and protractor method, compass method. Complete the pentagon. Complete the pentagon in front view. A dash, B dash, C dash, D dash, E dash. So on one corner, A, B, C, D, E on one base. On the other base, 5 more corners. 5 corners on the front base and 5 corners on the second one. So let this be F dash, G dash, H, I dash, and J dash. Draw its respective top view. For drawing respective top view, draw the projections from each and every point. And for this problem, the distance from vertical plane is not given. The distance from vertical plane is not given, so you can maintain any random distance. Better to maintain a standard value, what we are following, that is 20 mm. So before that, also identify the axis. How to identify the axis? Join the side midpoint to opposite corner. Side midpoint to opposite corner. Side midpoint to opposite corner. So this is the point O dash comma O1 dash, axis point. Now draw the projections from each and every point. A, B, C, D, and E. Now first base at a distance of 20 mm from XY line, and from this, what is the axis side given as? Axis side is given as 80 mm. Axis side is given as 80 mm. So project this for 80 mm length. Complete the shape of the top view. Mark the point, intersection points, projection from A. So A, B, C, D are visible. So those points must be nearer to the observer. So A, B, C, D, E. Next, F, G, H, I, and J. One more thing, O dash and O1 dash. O1 and O. Axis is coinciding with the DI. Now, when you are seeing exactly from top, this is the viewing direction. For drawing the top view, observe the figure. Observe the front view. DI edge is visible. So DI must be continuous. CH visible. Continuous. EJ visible. Continuous. But the edges BG and AF are hiding. When you are seeing in this direction, as it is inclined in this way. So these 2 points are on the other side of the viewing direction. So the edge AF and BG are hiding. So draw AF and BG with dashed line. AF and BG with dashed line. AF and BG. So with this we completed the projection of the prism when the axis is perpendicular to the vertical plane. When the axis is perpendicular to the vertical plane. Next condition as given in the problem. The axis is inclined at 40 degrees to the VP. Is it 40? The axis is inclined at 40 degrees to the vertical plane. So, the initial condition, the axis is perpendicular to the vertical plane. This is the axis line, is it? So, you have drawn, assuming the axis perpendicular to the vertical plane. Now, we have to redraw the shape in top view. We have to redraw the shape in top view. Redraw the shape in top view, making the axis inclined at 40 degrees to vertical plane. So first to draw an inclined line. Inclined at 40 degrees to vertical plane. Inclined at 40 degrees to vertical plane. On this line, construct the pentagon. How to draw the pentagon? These two sides are perpendicular to the axis, is it? These two bases are perpendicular to the axis. So, at any random distance on this line, draw a perpendicular to this inclined line. Draw a perpendicular line to this inclined line. Now, from this line, at a distance of 80 mm, as the axis length equal to 80 mm, so let this be point O. At a distance of 80 mm, mark point O1. Mark point O1. Now, okay, this is O1 and O. Now, passing through O, draw one more perpendicular line to the axis. Draw one more perpendicular line to the axis. Now, measure the distance from O to G. Measure the distance from O to G. O as center, draw an arc. Measure the distance from O to H. O as center, draw an arc. So these are G1 and H1 points. Similarly, measure the distance from O to F. O as center, draw an arc. F1. Measure the distance from O to J. O as center, draw an arc. J1. Now, draw the parallel line to this axis, passing through G. All these lines must be parallel to this 40 degrees inclination line. So now we have completed. Okay, actually these two are dashed lines. So represent the same notation. Draw these two as dashed lines. So we have redrawn the same shape. What is any doubts? We have redrawn the same shape with 40 degrees inclination. Name the other points. What are these points? Unmute your audio. How about you unmute your audio? Someone has, sorry, yes. I'm getting some disturbance. మీకు ఏమైనా డౌట్ ఉంటేనే మీ ఆడియో అన్మ్యూట్ చేయండి, అదర్వైజ్ కీప్ ఇట్ ఇన్ మ్యూట్. Yes. The points are E1, J1, D1, B1, C1. Similarly here, I1. Now we completed the top view when the axis is inclined at 40 degrees to the vertical plane. Simply redraw this shape. Now for getting the front view. Draw the projections from each and every point from top view. Line. Draw the projections from each and every point from the top view. H, G, I, F, J, B, C, projection from E. Draw the projections from each and every point from top view and mark the respective intersection points. Projection from E, C, D. Already these 4 points are existing on XY line and one more is the axis. Now identify the respective points. There is point A. This point A. A1 dash, B1 dash, C1 dash, D1 dash, and E1 dash. So if we join them, we get AB, C, D, E, A. One base. We're getting one base. Coming to the second, as you're seeing in this direction, when the axis is inclined at 40 degrees, we can see only one base. The second base is hiding, and in the second base, you can only see one or two edges like this. On the second base, you can see only one or two edges. But one base is completely visible. The base which is nearer to the observer is completely visible. So A, B, C, D is completely visible. So without any dot, join them with the straight lines. Coming to the second base, F, G, H, I, J. Mark the respective intersection points. F, F1 dash, G1 dash. I'm redrawing this. Just wait for a minute. Redraw the same shape here. Redraw the same shape here with 40 degrees inclination. After drawing the same shape, draw the projections from each and every point. H, projection from G, projection from I, F, J. Similarly, projection from C, B, D, A, E. Projections from each and every point from top view to the front view, and then a parallel line to X value, locus lines. Now, mark the respective intersection points first. Mark the respective intersection points, top base and bottom base. When the axis is inclined at 40 degrees, you can see the complete base, the base which is nearer to the observer. So, as we are seeing in this direction, you can see the A, B, C, D, E base completely, E, F, G, H base. See here, one complete base. What about the second base? Only one or two edges, depending on its orientation and their position. So, A1, B1, C1, T1 and E1. 5 points on the bottom base and 5 points on one more base, E, F, G, H, I. F, F1, G1, H1 dash, all these are the front views. H1, I1 dash and J1 dash. Join them with a, so what we observe, A, B, C, D, E, all the points are visible and are seeing in this direction. Point J is also visible. Possible hiding points are F, I, G, H. As you are seeing in this direction, point J is also visible. There is no restriction in the viewing direction. So, possible hiding points are F, G, H, and I, and also J. These are the possible hiding points. Now, as we already discussed, one base is completely visible. So, join AB, BC, D, E, A. Coming to the second base, first draw the lines which are on the boundary, which are on the outermost boundary with the continuous lines. So, I is on the boundary line. So, join IJ, JF, FG. IJ, JF, FG as continuous, and these are the only boundaries which are coming internal. So, join with these with the dashed line. Now, the remaining straight edges. So, till now, we completed the two bases joining the sides of the two bases. Now, the remaining one is the straight edges. Joining the straight edges. What are those straight edges? If you observe the front, we can identify easily. The straight edges are AF, BG, CH, DI, and EJ. These are the straight edges. edges joining respective points of top base and bottom base. EAF first. EAF, it is on the boundary, so join EAF. Next, BG. So BG and EAF are coincident overlapping. BG, EAF. Next, CH. CH. If you observe in this direction, if you observe from a top view in this direction, CH is on the outer other direction to the observer. CH is on the other direction to the observer. So we should draw CH as a dashed line. Draw CH as a dashed line. Next, DI, as it is on the boundary, draw it as a continuous line. Remaining EJ, where is EJ? EJ, nearer to the observer. So EJ is also continuous line. EJ is continuous line. So this is what the final view looks like. Join the edges which are hiding with dashed line and the continuous edges, visible edges as continuous line. One more thing is the axis. Projection from O, this is the point O, 1 and O. Join this with as an axis line. So with this we completed the position of prism when the axis is inclined to vertical plane at 40 degrees and resting on one of its rectangular faces on the ground. Do you have any doubts in this? So if you are having any doubts, unmute your audio or I will continue with to the next problem. Problem number 7. If you have any doubts, now let us go to the next problem, problem number 7. I'm typing it in the chat box.
సార్ వాయిస్ వినిపించట్లేదు సార్.
Yes. Hexagonal pyramid is lying on one of its triangular faces on horizontal plane with the axis parallel to VP, side of the base 30 mm, length of axis 70 mm. Draw its projections. So instead of giving the inclination, he has given that it is resting on one of its triangular faces. So actually last class we drawn the projections of a pyramid. So when it is in simple position, the base is in the horizontal position and all the corners of the base are joined to the apex. And these triangular faces are inclined to the ground. All these triangular faces, the faces which are joining from base to the ground are, base to the apex are inclined to HP in the general position. But here it is given as it is resting on ground. These triangular faces are resting on ground. I will show you the picture better, you will understand better. See the screen. So if it is in initial position, the pyramid is resting in its base, on its base with the axis vertical position. But indirectly has given that it is resting on one of its triangular faces. It is resting on its one of its triangular faces. Means it is in the position like this. With the base is inclined to the xy line, axis is inclined to horizontal plane. Axis is inclined to xy in front of you means axis is inclined to HP. So in this is the position. You have to complete the front view and top view. So now let us draw the pyramid in the initial position, that is axis perpendicular to the reference plane. Axis perpendicular to the reference plane. So it is given that the hexagonal pyramid is lying on one of its triangular faces on HP. So initial condition. So instead of like sleeping position, we'll assuming the pyramid in standing position. Instead of like inclined position, we'll assume the pyramid in the vertical position, that is axis perpendicular to the ground. When the axis is perpendicular to the ground, we can see the true shape of the base in top view. We can see the true shape of the base in top view. So ఇక్కడ top view draw చేసేటప్పుడు again two possibilities are there. Again two possibilities are there. That is hexagon in these two positions with two of its sides parallel to vertical plane and with two of its sides perpendicular to the vertical plane. So observe cheyandi, triangular face completely on the ground undali ante as the given the condition that one of its face must be on the ground condition. When you are rotating, you must rotate based on an edge. You must rotate based on an edge. Based on edge rotate chestene the complete face will lie on the ground. Suppose if you rotate based on a corner, if you rotate it based on a corner, what happens? It rests on an edge, not on the face. Face మొత్తం కాకుండా it rests on an edge if you rotate based on a corner. So whenever in any problem it is given as it is resting on a face, it may be prism or pyramid. Whenever it is given that it is resting on its face, you must rotate the solid based on the edge. If you rotate the solid based on the corner, what happens? It rests on a edge. It will rest on a edge, not on a face. If you rotate based on the edge, corner base, it completely rests on a face, rectangular face or triangular face, depending on the shape of the solid. Now, as we have to rotate based on the edge, it is an edge-based problem. In the initial view, we have to draw the solid with the edge perpendicular to xy line. Already we discussed it while discussing in the planes. Whenever it is an edge-based rotation or edge-based problem, we have to draw one of the edge, at least one of the edge must be perpendicular to xy line in the initial view. So, following the same rule, we will draw the hexagon with the edges perpendicular to xy line in top view. Perpendicular to xy line in top view. I am redrawing this. Now, as it is a pyramid, having only one base, let the base corners be A, B, C, D, E, F. So for pyramid, you have to draw all these lines joining towards the apex. You have to show all the lines joining towards the apex. So draw the diagonal lines. For a hexagonal pyramid, when you are seeing from top, you can see all these 6 triangular faces. You can see all the 6 triangular faces. This is the point O, apex point. Now, respect to front view, draw the projections from each and every point. So as it is resting on the ground in the second position, so initial position also, we must draw the front view as it is resting on the ground. So draw the base on horizontal plane, base on xy line. What are the points? A dash, F dash, B dash, C dash, D dash and E dash. Now draw the axis for given height. And join all the base points to the apex. Join AO, and if you observe from this direction, A is visible, B visible, C visible. So AO visible, BO visible, CO visible. So join AO, BO, CO. A dash O, B dash O, C dash O. D dash O, F dash O are being overlapped, so you can't view them in front view. So in front view, F dash and D dash are hiding. F dash and D dash are hiding. Now, in the second stage or in the second figure, you have to follow the condition. The condition is the pyramid is resting on one of its triangular faces. The prism is resting on its triangular faces. Pyramid, sorry. So we have to redraw this pyramid such that what is the triangular face? DOC. DOC is a triangular face. COB triangular face. AOB triangular face. All these are the triangular faces. So in the second view, we must draw with any one of the triangular face on the ground, means on XY line. So here if you observe, CDO is looking as a line in front view. So draw, first mark your point, name this as C1 dash, D1 dash. Name this point as C1 dash and D1 dash. Measure the distance from C to O, not the axis length. Not the axis length. Measure the distance from C to O. C as center, draw an arc, you'll get the point O dash. We'll get the point O dash. Now, for getting the remaining points, or for drawing the remaining points, measure the distance from D to A. Measure the distance from D to A with D as center, draw an arc. D as center, draw an arc. Measure the distance from O to D. Measure the distance from O to D. O as center, draw an arc. We'll get the point A dash and F dash. Join CA. Now we got the same pyramid in lying position with lying on one of its triangular faces on the ground. So for getting the B dash point, measure the distance from D to B. Measure the distance from D to B. D as center, draw an arc. D as center, draw an arc. Also join. So be careful. These two must be of same shape and size. These two must have same shape and size. Only variation is its orientation. Here it is in standing position, and in second view it is resting on one of its triangular faces on the ground. So after completing the second front view, draw the projections to the top view. So this is the point B and B dash, E dash. Draw the projections from each and every point. From front view and a parallel line to XY line from the previous top view. Mark the respective intersection points. Projection from A A1. Projection from B B1. Projection from C C1. D D1. E1. F1. Now, when you see it from top, when you see the pyramid, when it is resting on ground in top view direction, in this direction, we can see the complete base, is it? When it is resting in inclined position like this, we can see this complete base when you are observing the pyramid in top view. The entire, this means all the edges on the base are visible. All the edges on the base are visible. So without any confusion, join A, B, C, D, E, F, A with the straight lines. With the straight lines. Now also draw the axis line. O1. Now next step is join all the base points towards apex. Join all the corners of the base to the apex. So first, when you're seeing from top, point A and F are visible. as these are needed to the observer. A and F are visible. So join AO, FO continuous, ED, and you're seeing is it visible? But if you observe in top view, EO, BO are on the outermost boundary. So whenever in any solid object, outermost boundary must not be a hidden line. ఎప్పుడు ఎక్కడ పొజిషన్ వచ్చినా సరే we should take it as a general rule, that is outermost boundary is always visible. So join EO BO with continuous lines. Coming to CD, CD is on the base, which is on the ground. So these edges may hide. So draw DO and CO as dashed lines. Draw CO and DO as dashed lines. So with this, we completed drawing. So only thing, already the initial position problems we discussed in the last class. Only addition is when the axis is inclined to any of the given reference planes. So coming to the dimensions, height of the axis and side length represent these two dimensions. Height of the axis is 70 mm and base side 30 mm. Still, any of you having doubts in this? Projection of a pyramid. And remember one more thing. I'm going to discuss a very few problems in projections of solids and sections of solids. Why? Because I'm going to give you a set of 30 questions as assignment. Set of 30 questions is everyone need not solve all those 30 questions, but for each students I'm going to give 3 questions, minimum 3 questions, unsolved problems in class. All those are from the previous question papers or from the textbook. So you have to complete those problems as a home assignment. So as per our syllabus or regulation point of view, in third unit you have to submit the home assignment. So I will give unsolved problems as home assignment. Home assignment is not simply copying. You have to try on your own. So, do you have any doubts in this? If I
సార్ మీ మైక్ మ్యూట్ లో ఉంది
సార్ సార్
సార్
వాయిస్
okay. Go through problem number 8. I have typed in the chat box. Cone. So now we completed prism and a pyramid. Next problem is on the cone. Cone is resting on one of its generator on HP with the axis parallel to vertical plane. With the axis parallel to vertical plane. Cone base diameter 60 mm and axis length 80 mm. Draw its projections. Same as the previous problem. That is a hexagonal pyramid. Here it is a cone. Initial position in the standing vertical position, and in the second position it is resting on one of its generators on the horizontal plane. It is resting on one of its generators on the horizontal plane. So you remember one more thing. I'm trying to explain you the different models. So these are the only possible models. But in examination, suppose see here in sixth problem, I have given the pentagonal prism. Examination will get the around the same condition with hexagonal pyramid. Base may change or the prism may be converted into pyramid shape. So different possible methods I'm explaining. So you're going to understand by seeing the assignment questions how this can be varied. So try to understand the concept. So always first we will make the axis perpendicular to any of the reference plane. So here it is given that the axis is parallel to VP. Already the axis is parallel to VP. So we will assume when it is resting on the ground means whenever the pyramid is resting on the ground, pyramid or cone resting on the ground means the axis is definitely making an inclination. The axis is making an inclination with the ground. So the initial view is we will assume the axis perpendicular to the ground. When the axis is perpendicular to the ground, we can see the true shape of the base in top view. We can see the true shape of the base in top view. Draw the true shape of the base in top. The true shape of a cone is? What is the true shape of the cone? True shape of the base? It is?
Circular.
Circle. So draw the circle in top view. And is there any distance given? Distance from vertical plane is not mentioned anywhere in the problem. So it can be at any distance. So with the given dimension, draw the true shape of the base in top view. So I'm drawing again. Better divide this circle into 8 or 12 equal parts. Divide this circle into 8 or 12 equal parts. So if you go divide it into 12 parts, you will get more accurate shape in the next view. If you divide it into 8 parts, you will get a little accurate. But dividing it into 12 takes time. So here I am dividing it into 8 parts. Naming the corners as A, B, C, D, E, F, G, and H. So for drawing the top view, draw the projections from each and every point. We get the same projection from H and B. So mark the respective points on the HP. As in the second condition, it is given as the cone is resting on one of its generators on the ground. So initially, we will draw it on horizontal plane. So the points are A dash, B dash, C dash, D dash, E dash, F, G, H. Now draw the axis line. This is the axis point, apex point. Draw the apex point. Find the point as O dash. O dash. Join the outermost generator. Join OE and OA. Join OE and OA. No need to draw the remaining generators. No need to draw the remaining generators. And even in some textbooks, even it is shown, draw it with a 2H pencil as thin as possible. But because if you draw all the generators, it looks confusing. So just draw only the outermost generators. It is sufficient drawing. Now coming to the second view, it is given as the cone is resting on one of its generators on the ground. It is resting on one of the generators. So you can take any of the generators, the outermost generators, AO or EO as reference. So I am rotating in this direction. So first mark point E1 dash. Mark point E1 dash. Measure the distance from E to O. Measure the distance from E to O. ES center, drop R, we get the point O1 dash. E1 dash and O1 dash. Now, measure the distance from E to A. It is nothing but the diameter of the circle given. It is nothing but the diameter of the given circle. So, measure the distance from E to A. ES center, draw an arc. Now, measure the distance from O to A. Measure the distance from O to A. OS center, draw an arc. We'll get the point A1 dash. Join AO and EO. So we'll get the same triangle but with different orientation. Means the cone, here it is in standing position. Second position, it is resting on its ground, on one of its generators. Now, for getting the remaining points, take compass, measure the distance from A to B. AS center, draw an arc. You get the point B1 dash and H1 dash. Measure the distance from A to G. AS center, draw an arc. This is the point C1 dash, G1 dash. Measure the distance from A to D. AS center, draw an arc. D1 dash, F1 dash. Just represent the axis, no need of any other lines. The cone, the second position when it is resting on its generator. Now, draw the projections from each and every point. And locus from the previous. Only axis point up to this end. Base points are only up to this, so no need to extend beyond this one. Mark the respective intersection points. A1, B1, C1, D1, E1, F1, G1, H1. Now, if you observe from top, complete base is visible. Complete base is visible. So join all the base points with a smooth continuous line. You'll get an ellipse. And now join the outermost points. The outermost points are C and H. Actually, here we have shown the lines AO, EO. And in this view, the outermost points are C and G. Join GO and C. The cone, top view. So no need to draw all the generators. Remember, I am repeating this. Just only the base and outermost generators is sufficient. So this is the position of the cone when it is resting on ground on one of its generators. Coming to dimensions, you can also represent the diameter like this by extending the two diameter endpoints and represent the diameter, and in front view the axis height. So do you have any doubts in this cone? Now let us go for the next problem. Cylinder. I'm typing it in the chat box. Last problem in this sheet. Actually, we skipped one more one. One more one. That is fifth problem. After ninth problem, I will explain the fifth one. A cylinder 50 mm base diameter and 80 mm long, having axis parallel to VP and inclined at 30 degrees to HP. So axis is inclined at 30 degrees to HP in this condition. Initial position when the axis is inclined to HP. So always observe the axis inclination. Here in this problem, the axis is inclined to HP. So initial condition, draw the initial condition with the axis perpendicular to HP. So in which you can see the true shape. When the axis is perpendicular to HP, in which we can see the true shape of the base.
Side view.
It is only parallel to HP, not parallel to VP. Forget about parallel to VP. Sorry. Perpendicular to HP. So whenever the axis is inclined to reference plane, make the axis perpendicular. Axis inclined condition A reference plane is the R reference plane ki make it as perpendicular. So in this problem, it is given that the axis is inclined at some theta degrees to HP. So we'll assume the initial position with the axis perpendicular to HP. So a cylinder. So let's send this. When the axis is perpendicular to HP, this is the position. We can see the true shape of the base in
Top view.
Actual second condition is given as the axis inclined to horizontal plane. So we're assuming axis perpendicular to HP. So we'll draw the true shape in top view. True shape of the base in top view. Divide this into 12 over 8. So let this be A, B, C, D, E, F, G, H. So as it is a cylinder, if we are dividing top base into 8 parts, bottom base also having 8 same respect to 8 points. So A, B, C, D, E, F, G, H on the top base, on one base, I, J, K, L, M, N, O, P on the other base. As we assumed, I to P, IJKLMNOP on the base, bottom base. Why? Because these we are represented as a hidden points, and ABCDF we are represented as a visible point. So ABCD must be on the top, IJKLM must be on the bottom. So first project it onto. Distance from horizontal plane is given. Distance from the reference plane is not represented in the problem. So you can maintain any distance. Or even you can also draw it on XY line. So I am drawing extending to a height of 20 mm above XY line. Drawing all the projectors. And first base, and next drawing the axis line as per the given dimension, completing the rectangle shape. So if you want, you can also draw this with very light pencil, 2H pencil. So remember, these projections must be with 2H pencil, and even if you don't draw them also, it is correct. Just I'm drawing only for marking those points. So the points are A, B, C, D, F, G, H are on the top base. A dash, B dash, C, D, E, F, G, H. As you are seeing in this direction, F, G, H points are hiding. So similarly, in the bottom base, I, J, K, L, M dash, N, O, P dash. So one more thing, don't represent as P, N tarvata represent them as P and Q. Why? Because we are giving the O for axis endpoint. IJK, LM and PQ. Skip the letter O. P dash and Q dash. Now, what is the condition given? The cylinder is inclined at (30° to the HP. The cylinder is inclined at the axis parallel to VP and inclined at 30° to the HP. So, draw a 30° inclination line. Draw a 30° inclination line inclined to HP on somewhere at random distance. Mark the first point, axis point O, and what is the distance between these two? Nothing but the axis length. What is the axis length given in problem? Axis is 80 mm long and diameter 50 mm. So from O at a distance of 80 mm, mark point O1 dash. O dash, O1 dash at a distance of 80 mm axis. Now at these 2 points, draw perpendicular line to the axis. The base is perpendicular to the axis. So draw perpendicular line to the axis line at these 2 points. These 2 points must be at a distance of 80 mm axis length. Now measure the distance from P to L. Mark it. Measure the distance from P to M, P to Q, P to I. Similarly on the other side, and now draw the lines parallel to axis line. We have redrawn the same shape with 30 degrees, axis inclined at 30 degrees to XY line. Now the points are I, J1, K1 dash, L1 dash, M1 dash, N1 dash, P1 dash, Q1 dash. On the other side, A1 dash, B1 dash, C1 dash, D1 dash, E1 dash, F1 dash, G1 dash, H1 dash. So representing all the points in the second front view. Third step. Draw the projections from each and every point. From top view and projections from front view and parallel lines from top view. Mark the respective intersection points. Mark all the respective intersection points. A, B, C, D, E, F, G, H on this side. A1, B1, C1, D1, E1, F, G, H. A, B, C, D, E, F, G, H on one side. I1, J, K, L, M, N, O, P. Top base and bottom base. So be careful here. When you're seeing from top, A, B, C, D, F, G, H, complete base is visible. The complete base is visible. So join all these points with a smooth curve. Now coming to the second base, we can see only half of the base visible. Because when you're seeing from top, see here, when you're seeing in this direction, we can see only one base. The second base, we can see only half. Second base, we can see only half base. One base, we can see the complete boundary when it is inclined to the viewing direction. One side, you can see the complete base, and on the second side, you can see only the half. Half ela decide chestamante. Outermost points. What are the outermost points? OK. So first draw the outermost generator with a continuous line. Join outermost generator with a continuous line. And in this, always, we discussed in the previous one, always whenever the line is or edge is on the solid boundary, it is visible. So join these with a continuous line. This is the continuous line, and the remaining half, join the remaining half with dashed line. The remaining half with dashed line. Outer one, a continuous line, and the inner one with a dashed line. And finally the axis. Here also, don't forget to draw the axis. So do you understand this? Or any of having doubts? So actually, ఈ figure positioning we have drawn number of times in physics experiments while drawing the tumbler shape or a flask shape. What we are doing? Have you drawn this shape or not? In physics lab experiments, drawing mostly. Is it or not? Cylinder, upper side completely visible. On the bottom side, the inner line is hiding. The same shape you are going to get like this. But we are drawing as per the procedure. Now, meanwhile, go through the last problem, which we skipped, problem number 5 in the sheet. Why I'm explaining problem number 5 at the end is, it is somewhat different compared to the remaining. It is not a regular prism or pyramid, it is a tetrahedron. Tetrahedron is, I already explained it in the introduction class. Tet means 4. Hexahedron means a cube. Why? Because it is surrounded by 6 flat surfaces of equal shape and size. So you call cube as a hexahedron. Similarly, when a solid object is formed by 4 equilateral triangles surrounded by 4 equilateral triangles, it is called as a tetrahedron. So it is almost looks like a triangular pyramid. Suppose if you draw a triangular pyramid, all the base corners are joined towards the. So this is the triangular pyramid, is it? Triangular pyramid, if you observe, base is in the shape of a triangle and all these faces are triangle. Total number of triangles are 4. But triangular pyramid is not equal to tetrahedron. Tetrahedron की triangular pyramid की difference ఏంటంటే, tetrahedron లో these triangular faces are also equilateral triangle and has the same shape as the base. But here, it may have a different shape. All these triangles mostly are of isosceles triangles. Depending on the axis height, this changes. So if the axis height in such a way that all the 4 triangles are of equal shape, then it is called as a tetrahedron. Similarly, square prism and cube, what is the difference? When the axis length is more than or less than the side of the square, it is called as a prism. When the axis length is equal to the side of the square, then will form the shape of a square. Similarly, triangular pyramid and tetrahedron are, you can compare. So tetrahedron is looks like a triangular pyramid. Only variation is all the faces are of equal shape and size. So if we observe the problem, here they doesn't give the axis height. Similarly, already we done the square problem. Square problem chesnappudu they will give the dimensions only in terms of side of the square but not the axis height. Similarly, for the tetrahedron, we don't have the dimension of axis. A tetrahedron of side 60 mm resting on one of its faces on the ground with an edge of that face inclined at 40 degrees to the VP. Draw its projections. So here there is no dimension like axis height. Read the problem clearly. A tetrahedron of side 60 mm is resting on one of its faces on the ground. Means in top view you can see the true shape. In top view we can see the true shape of the base. And for drawing, what are the other conditions given? With an edge of that face is inclined at 40 degrees to the vertical plane. So with an edge of that face is inclined at 40 degrees to the vertical plane. So you must draw the tetrahedron base in top view. This is the simple position. So first draw an inclined line at 40 degrees. Draw an inclined line at 40 degrees. And based on this 40 degrees inclination line, construct the equilateral triangle. So let the sides be A, B. With the A center, I'm drawing a little bit larger one so that you can see the shape clearly. First base, let this be A, B. A as center, draw an arc. B as center, draw an arc. We'll get an equilateral triangle. With one of the base edges is inclined at 40 degrees to the reference line XY line. Now, as it is in the shape of a pyramid, we should join all the base corners to the apex. Join corner to the opposite side midpoint. So highlight only corner to the midpoint. Leave the remaining line with true edge. Because this is only an imaginary line. This is the top view of a tetrahedron. Top view of a tetrahedron. For drawing the front view, draw the projections from each and every point of the base to front view. Draw projection from each and every point on the base to front view. Projection from A, projection from B, projection from C. So as the bases are resting on the ground, the points A dash, C dash and B dash, and this is the axis point. So O1. What is the axis height? Axis height identify చేయటం ఎట్లా? So for this one, we have to follow a simple procedure. Here, all these are the slant edges. Tetrahedron now, square conditioning, all the edges are of equal length. Cube key. For cube, what is the condition? All the edges are of equal length and all the faces are of equal shape. Similarly, in tetrahedron, all the faces are equilateral triangle of same dimension and all the edges are of equal length, including the slant edges. base edges and slant edges must be are of equal length. Means BC, CA, AB, all these three are equal. Why? Because we have drawn an equilateral triangle. In the same way, BO, CO, AO must be equal length. BO, CO, EO must be of equal length. But here we don't get the equal length. Why? Because we are drawing it in the inclined position. We are drawing in the view in which it is inclined to the viewing direction. So we can't see the true length of the line. True length of the line we can't see in these three. But actually AO, BO, CO must also be equal to 60 mm. So 60 mm రావాలి అంటే what we have to do is all these three lines are inclined to vertical plane. In all these lines are inclined to XY line in top view. Similarly, front view draw chestha kuda all these lines will be inclined in front view. So means all the three lines AO, BO, CO are the lines inclined in to HP and VP, means inclined to both the reference planes. Inclined to both the reference planes. So but manaki true length kavali ante at least it should be parallel to one of the reference plane. True length identify challenge, it should be parallel to any one of the reference planes. So a condition ki em chestamante we will make any one of these lines parallel to XY line. So with OS center, OC radius, OS center, OC radius will draw an arc and get the point C1. Get the point C1. Project this point C1. Project this point C1. Now this is C1 dash. This is the line C1 dash. Now from O1, draw an axis line or draw a line with 2H pencil initially. Now with C1 as center, C1 dash as center and length equal to the base length. What is the base length given in problem? Side length is 60 mm. So C1 as center, 60 mm radius. Draw an arc on this axis. Draw an arc on this axis. So this is the apex point O dash. Now C1 O1 line, C1 dash O dash line is equal to 60 mm. So slant length also equal to the same length of the base. So forget about this line. Only join BO, CO and point A is nearer to XY line, other in the opposite to the viewing direction. So join AO with the dashing line. AO with the dashing line. No need to draw it. No need to draw the line. C1 dash only. Just show the line or draw this with a 2H line. Draw this with a 2H pencil. Draw all these lines with HB. Only C1 O dash, C1 dash O dash line with 2H pencil, as it is only the construction line for calculating the axis height. So you should follow the process for a tetrahedron. Actually, tetrahedron is not specified in your syllabus, but as an extra topic or even examination by mistake ichina, we can't say it is an out of syllabus. That's why we are explaining the tetrahedron problem also. Complete this problem in the sheet. So with this we completed first half of the third unit. Third unit lo half part complete అయిపోయింది. And remember one more thing. I'm stopping the recording.